The New Wave Post-Punk Security Hour continues. This time, we think of Nena and 99 Luft Balloons with the English lyrics, "Back at base, bugs in the software flash the message, something's out there." And since the song pretty much ends with cities in ruin, that seems like a good reminder to secure your code. Which means, this week we talk with Daniel Hampton from Fastly about the threats to APIs and some strategies for defending them. In the news segment, covert channels of not much consequence, a new protocol reaches confidence, bounties for product abuse and fraudulence, Amazon Sidewalk's privacy competence, and more. Buy a bag of balloons and stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. For teams looking to inject some security into the DevOps lifecycle, the Uptick Security Analytics platform offers complete security observability for your cloud workloads, including hosts, VMs, containers, and micro VMs. Uptick analyzes builds in development and at runtime for real-time detection of misconfigurations, vulnerabilities, and malicious behavior. Security Weekly listeners can sign up for a free 2-week trial by visiting securityweekly.com/upticks. Are you looking for a solution to protect your web apps against the most business-critical security vulnerabilities? Unleash the power of automated ethical hacker knowledge with Detectify for continuous coverage and relevant security vulnerability findings. Upgrade your web app security with speed and scale and start a 2-week free trial at securityweekly.com/Detectify. Go hack yourself. Whether you need to manage bots, protect cloud applications at runtime, stop formjacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva.
This is episode 153, recorded June 7th, 2021. I'm your host, Mike Shima. I'm here with Tyler Robinson. Hello, Tyler. Welcome aboard.
How you doing, Mike? Good to see you this morning, man.
Good to see you. Thanks for joining. Also here with John Kinsella. Hello, John.
Hello, Mike.
That sounds just like you, John, and not at all like I'm filling in for when you join us later.
Thanks, Mike. Why don't you read the announcements now?
I will. Security Weekly is more than happy to announce that we will be at InfoSec World 2021 in person, October 25th through 27th. This year, our annual partnership with InfoSec World is extra special as we are both business units under the Cyber Risk Alliance brand. What does that mean for Security Weekly listeners and InfoSec World attendees? Well, you will get to see and hear from many of the Security Weekly team at the event, and you will save 20% off on your World Pass. Visit securityweekly.com/ISW2021 to register using our discount code. Do you want to stay in the loop on all things Security Weekly? Visit securityweekly.com/subscribe to subscribe on your favorite podcast catcher or our YouTube channel, sign up for our mailing list, join our Discord server, and follow us on our newest live streaming platform, Twitch. Daniel is a senior solutions architect at Fastly, where he is responsible for assisting customers in the post-sales process by delivering a pragmatic and effective application security experience. Daniel recently joined Fastly through the Signal Sciences acquisition. He has spent a total of 16 years in the enterprise security space, covering database, web application, and container security, policy management, and managed services for small to medium businesses. Hello, Daniel. Thank you for joining us.
Hey, Mike. Pleasure to be here.
So we're happy to have you here, especially, as I mentioned, to talk about API security. And first, when I look at API security or immediately think of API security, we have the OWASP top 10 for the web, but we also have an OWASP top 10 for API. And there's kind of a lot of overlap, but we have two unique lists, two different lists for them. And so maybe let's kick off a little bit about just talking a little bit of the differences between what does an API bring to the table that we need to worry about? Or maybe what makes API security a little bit more unique than just worry about the web in general?
Yeah, I think it is worth highlighting the differences, but I think more important than anything else, it's notable that most of the top 10 and any security threats in general, for that matter, are overlapping because at its basic function, an API is a web application of sorts. The only differences really are what it's used for, how it's used, and then some of the challenges with implementing security controls that we don't necessarily have with web applications. So, not sure where you want to focus first.
Well, I think you make a good point that web applications are definitely built on top of APIs. So everything's kind of an API, but maybe it's more the fact that some APIs are more mature than others in the sense of their design and what they're handling. And here I'm starting to go into the ideas of REST and the contracts that they may have. But these are some of the design perspectives. But on the security perspective, there's certain tools that you can't necessarily do the same with an API that you might with a web app. And here I'm starting to get to things like authentication. Where you can't really throw a CAPTCHA in front of an API, especially from a B2B API, or if you're connecting services to each other. So already we're starting to get into a little bit of this idea of, well, how do you prove identity between APIs? But then there's also just the aspect of there's so much traffic going into APIs. And it's, on the one hand, that's good. That's what the APIs are designed for. But on the other hand, that's where the abuse comes from. And I'm kind of leading us down the line to talk maybe less about the idea of cross-site scripting and SQL injection and more of what does abuse of an API look like that might be different or unexpected for a development team who's just used to, quote unquote, the web, or not as necessarily as focused on that business logic maybe.
Yeah, and which also presents with an interesting question. So when people ask, how do we secure an API versus a traditional web application, the methodology is very, very similar. You have to know what the web application is being used for. You have to profile the activity. You have to understand what is expected versus what people are doing. And then you also have to understand what the business wants to allow for that web application. The same methodology holds for an API. If you don't know, and a lot of the time security teams really struggle with knowing this because they don't have direct linkages to the development team. If you don't know what an API is being used for, it's going to be a major challenge to actually protect it, because you have to, at the base level, profile the activity that's hitting an API to effectively secure it, because you can't throw in as you said, a CAPTCHA, or more effectively a multi-factor auth type situation to prove identity, or to manage the identity of whoever is hitting the application. And that is one of the major challenges, which is where a lot of rate limiting comes into play, and a lot of, this is the sort of activity we want to allow to hit our application. Everything else we don't, which is another challenge, because you're not really required to send anything, right? If I just want to curl an API, or I want to hit it with a web browser, whatever, I can do that, unless there is a control in place that is saying I can't. So building controls like that is generally an approach that is a little different from a standard web application. But again, the methodology has direct overlap.
Does that methodology or the security concerns need to be taken into account prior to the deployment or during the development lifecycle in order to properly get APIs secured? Or can this be done post-development?
So both. Ideally, the answer is yes. It'd be great if during the development process, developers were to say, you know what, here's some things that we can do to document and sort of fingerprint what our API activity, anticipated activity, is supposed to look like, and then pass that information along to the security team so that the security team can use whatever controls they have in place, or acquire a security control that will allow them to permit certain activity. Because, right, if you look at how firewalls are traditionally implemented, not thinking web application firewalls, just a firewall, security, just a network firewall. ideally, you whitelist or allow list activity. You permit certain types of activity. You don't worry about blocking stuff. You think, this is the sort of activity we want to permit. Everything else is blocked by default. If you could do that with a web application or an API, that'd be great. But it's really a challenge because you have to know what is being done, what the application was designed to do. And then users have a tendency to show us interesting ways that our applications can be used. And APIs are no different. We've got a lot of challenges where we'll have an API, say, that validates credit cards, or that shows us a bunch, say, enumerates a bunch of store locations for a specific locale, right? We don't really anticipate that people might go, all right, I can use this to validate this massive stolen list of credit cards that I have, or potentially do the same thing with, say, stealing an entire list of, what a search engine is going to be enumerating to populate something else, a storefront somewhere else, add a middleman, purchase tickets, all these things.
I love the credit card example because to me that stands out as you have an API that's actually pretty well defined for the payload that it's expecting. Basically, 16 or so digits, maybe a expiration date, maybe a CVV in case, depending on the what it's supporting. So you can say, well, we're just looking for numbers essentially, and you can avoid that whole aspect of all the SQL injection, blah blah blah, all those attacks. But you pointed out that if somebody has that group of stolen credit cards and they're abusing that endpoint to enumerate and say they need to figure out what the proper expiration date is for a card or what that CVV is for a card, if they can just hammer that endpoint until they get that HTTP 200 response instead of some other error, that's a great use case for the attacker, and that's just abusing the product. And I think that's too where you're starting to get that idea of here's where the rate limiting can come in as to be a defense. So I'm curious, as you start to talk about this, how have you seen either like the security teams talk with their developers or vice versa, and sort of that threat modeling in the sense of what's the business context of your application and how can rate limiting or what help here, or what are really the sensitive workflows? How do developers and security teams identify these areas?
Exactly. So I like what you just brought up there. This brings up a significant challenge, and it kind of goes into what Tyler was talking about a second ago. If you know that an API is going to be well defined, like in the example we just gave, you can do a variety of things to secure it on the development side. But it isn't really, and we talked about this a little bit before, you can't put all these impetus for security and controls on the development team. It just doesn't work well. It's not what they're there to do. They're there to build an application and say, all right, this is serving whatever function the business needs it to do. It's ideal if you can bake security into it, but realistically, it's the security team's job, if you can, segment it out that way, to implement any controls that are needed. And if you build this application and you say, well, we're not going to give any generic, we're not going to give any specific response codes or any specific responses, but you could potentially have some information that says this credit card or whatever it is, whatever type of data you're trying to enumerate there, we're going to respond with something on the application side that's invisible to the client, and we can use it on our load balancer, or we can use it on our WAF or somewhere. We can strip it going back to the end user, but we have that to leverage when we're trying to determine the reason why something is happening. And you can take those and build pretty good security controls out of them. But it's
now, is that where
done.
conditional rules? Is that where the conditional rules and some of the more advanced features for a little bit more sophisticated WAFs come into play?
Yes, exactly. So what we're talking about there is not necessarily IP-based rate limits that you can put into play, or
we all know those work, right?
Say what now?
So, because we all know those don't work, right?
Yeah, you can try, but ultimately people figured out pretty good ways to get around those. And if it's only IP based, you're going to struggle. You've got to add something like IP plus header, IP plus something, key value pairs in the body, whatever, to make it a little bit more, or cookie value, for example.
So then that does lead to that question of how do you model a good rate limiting? Because there's one thing, do I just say, I don't want this to get hit more than 1,000 times a second, regardless from one IP or many IPs? Because there's also, of course, the dangers of a self-induced denial of service from misconfiguring a good rate limit. So there's that aspect, but there's also figuring out what's the behavior of the traffic. I think that's kind of what you're getting to there, beyond just based on IP addresses. So what are some good ways that you can set up that analysis to start looking for behavior? And is that something that can be done in the application itself? Is it something you have to do more at the traffic layer? Who ends up being responsible for that kind of work, I think, is also where I'm going with that.
Yeah, it's really well put. You definitely have the right way, if we were to use it, if we were to define it that way, to implement a rate limit, and definitely a bad way to do it. Just to arbitrarily say, well, we think maybe 1,000 or 500. Let's just go ahead. Let's go with that number and put it in front. And people have done that. And in the case of a reactive security plan where we have a team that says, oh, shoot, our endpoint's being used this way right now, and it's causing major problems, we have to throw something in front of it. You can't really take a measured approach. You have to say, well, let's pick this number and hope it doesn't break things, but already things are in a broken state because of a DOS that's happening, right? So we're gonna choose a number like that. You sometimes have no choice other than to do it that way. But ideally, what you've done is proactively built rate limits in to your API, and the right way to do that is a couple of things we got in place that we can build out a methodology around it. It's ideal to have lower environments that you can play with, but ultimately you are going to have to look at production level traffic, because again, we're not sure what we need to rate limit until there's something hitting us. And once we see that traffic and we can profile it a little bit and say, all right, well, this looks like it's above board. This is normal traffic. Then we have a couple outliers over here. And then we see that there's potential for abuse here. If we can define a couple of those things simply by looking at the traffic before we're in the middle of the thick of an attack, that's very nice. Then another thing that we can do is take one of the lower environments and actually build out, say, a load testing script, for example, and put some of the traffic that we're looking to rate limit into that, and test our rate limits before we roll them necessarily into production. But again, implementing a rate limit in production is kind of how you're going to have to do it. And if you have a tool in place that allows you to simulate a block, most WAFs and next-gen WAFs will allow you to have a logging mode or a non-blocking mode where you can indeed see that something would have been rate limited if a threshold was breached, instead of just directly rate limiting it. You can do it that way. So you build things and you take an arbitrary threshold like we just talked about, and we ratchet it down a little bit, and we see what happens if we ratchet that level down to a level that's ideal for us. And ideally, you're not doing it, again, based on just an IP. You're doing it based on a very specific set of criteria. Once you have that in place, you want to get as specific as you can and not rate limit anything that is outside of your use case. Yeah. And if you can do that, that's good approach.
Does APIs provide a little bit different challenge where there are a lot of things you may not consider that are going to be programmatically interacting with the web application, where something like users, they may be slower, they may be interacting in a certain manner. Programmatically, developers, even outside of your company may interact with your API very differently, and they may have a different approach in how they do those interactions. So is there kind of a different approach you must take from an API standpoint? And then to kind of follow that, as you're learning to secure the APIs, how do you go about learning API security versus web application security? A lot of people don't really understand the API level, and so really getting a grasp on what those differences are and how to go about learning more about API security versus just their web application security.
Yeah, so you bring up a couple interesting points there. So first of all, OWASP is great. It's a good starting point. If you take a look at the top 10 there and you start just going through the list and saying, all right, are we covered here? Are we covered here? A lot of the time, working for a vendor, right, we get security questionnaires from our customers asking for us to give them, do we cover this OWASP top 10 list? And they want to know how we do it. You can go through that and do exactly that for your vendor, see what their response is. Hopefully they have one. And then you can see how well you have implemented some of the recommendations that they've got. Another situation, though, that you brought up was the challenges involved when you've got an API. I mean, if you've got a web application, you pretty much expect web browsers to be hitting it. So you can look at things like user agents and not all the time, of course. That's an optional header, but you can see basically what's being done over a web browser, and then you can see some of the things that are being done outside of a web browser based on user agent or absence of user agent or a handful of other things. An API is similar. If you have on the development side, a lot of what I've seen, it could be hit or miss. It's one way or the other. Either a dev team has said, here are the user agents that we're going to use, here's what they look like, and this is a known user agent hitting the API. So you can profile based on the known activity. Then you can take anything else that's outside of that, look at it and say, all right, well, we're not sure who this is. This isn't an open API. Anybody could be hitting this. And we have a lot of unknowns when it comes to vendors hitting us, but our known activity is the stuff we want to look at. So again, the profiling aspect of things. If you take a look at your knowns, then you can go through the unknowns and categorize them in terms of different types of behaviors, and you can decide what you want to allow. Some of that it's a little bit of trial and error when it comes to implementing controls. You do your best to try to make sure you're not going to be stopping legitimate activity, but when you're building these things, it can be tough. And if you're, again, doing reactive security and building things to try to solve for an attack, you're going to have a lot more in the way of vendor feedback loops that are necessary to make sure that you're not breaking things long term for people while you're trying to stop an immediate problem. Ideally, though, with proactive security, you have a whole lot less of that.
Yeah, and I think a lot of what you're describing too is just that in the spirit of raising the attacker cost, in the sense of it's really easy to shed off a lot of traffic that's just coming from a bash script around curl or something that's been cribbed together to enumerate against an API, because it just doesn't look like authentic traffic. As you're saying, it just needs some particular headers, or it just has a different profile to it. So I do want to shift us back or kind of pick up one of the things we were talking about from the types of attack angle, in the sense of attackers, will have to raise their costs, start to impersonate more legitimate traffic, authentic traffic, but they're still going to be enumerating this data. And you hit a little bit of it just talking about carding and, testing a credit card endpoint. I'm curious, do you have some advice or some ways that, some seeds of conversation that a security team could take to developers to start talking about, these are some interesting and perhaps some unique threats to APIs, or here's some different ways that attackers might be trying to enumerate data because of APIs. Just trying to figure out what can be helpful to kind of kickstart that type of conversation around where are the sensitive areas in our app that we should be applying this type of rate limiting and traffic profiling to.
Yeah, and that's one of the things that is, I think, most useful to this discussion is figuring out how to open up these communication channels and figure out how to bake API or web application security into a product before it goes live, or to make some changes after it has gone live. And that has to involve a conversation between the security and the development teams. So again, you take a list like OWASP and you say, hey, here's some of the things that we've seen. We need to know a little bit more about what this API is intended for. And we understand that you on the development side or you're building this for a purpose. Could you please provide us a little bit of insight into that? And by the way, here's the list of the things that we're looking for. These are some use cases that we have seen. Provide a couple a couple examples of what we've seen in the wild. And OWASP has a lot of those. We've got a lot of those. There's stuff all over the web that provides a lot of good resources for how attackers are hitting different things. And if we can provide a concise list, because developers are busy, security teams are incredibly overworked, over alerted, over busy, all these things. If we can build something that's canned, concise, and helpful and understandable to our dev teams, generally they are willing to help us a little bit, maybe provide that header that has some information that we can use in our security tool, right? With that additional context for why a failure is taking place so that we can build a rate limit into it. There's all kinds of stuff that can be done there, but communication is key for that.
No, clearly. I'm curious too, then, we're talking about, like, you went through a lot of the resources from OWASP, resources known about types of attacks against webs, against APIs. Are there some false assumptions, though? Maybe, we don't necessarily need to go back and restart everything from first principles, but as a security team or developers are coming to a security team to say, to close that gap between, we need some type of protection for this API, are there certain assumptions that they should avoid, or certain types of conversations they could skip over because they don't apply to an API when they might have been thinking this is how we did things 10 years ago, but the modern approach has moved on from that and we're doing something different?
Unfortunately, I don't think so. I think that it doesn't make a whole lot of sense. So I've had a lot of conversations with teams recently that say they don't need to worry about OWASP injection type attacks in their APIs. And I think that's pretty naive, because when you have an API that you build out, yes, you'd like to think that your dev team has considered these things when they built it, and they've done a lot of testing and stuff like that. But you don't know what you don't know. And assuming that your API is protected against OWASP injection, cross-site scripting, any of these normal traditional attacks that we've seen and are protecting our web applications against, aren't going to be present in APIs. I think that it doesn't work, and it muddies the water a lot. Also, even if your application isn't vulnerable, it doesn't mean attackers aren't going to try. And if you don't have a control in place that is going to let you know that they're trying, then you're missing out on some valuable information, because it can let you know. We talked about identity at the very beginning. It can let you know that someone or something, some type of behavior, is an attacker trying to do something. Then it can allow you to watch them or redirect them to a honeypot and then watch them in a little more constrained environment. There's all kinds of things that you can do.
Yeah.
And speaking of not knowing what your
go ahead, Tyler. Yeah.
I said, speaking of not knowing what your application may do when attackers are trying interesting things against your API, that's insight A that you should have, because that is valuable to you, but you may not understand what's going on and why your application is freaking out, because, we get a little bit creative sometimes, and half the time I would say the stuff that scans you out on the internet and the interesting things hitting your API, they're probably not well thought through, and they're probably not very targeted. So let's see what your application is going to end up handling.
Exactly. Yeah. A lot of the time. I'm sorry. And Mike, I think you had something else to add there.
No, well, I was going to say too, and maybe this ties into, I think, to Tyler's comment as well. I want to poke a little bit at the you in how you were describing that, because you already brought up once, it's important to have the conversation between security and developers. I think everybody agrees to that. And I'm kind of curious too, especially when Tyler's pointing out, there's a lot of attacks that are just possibly the shotgun approach, just attacks being spread randomly against targets. And the idea of you want to know what's going on with your app. How have you seen, or who is the you in those sorts of scenarios, or what are the successful ways to make either the you in that scenario the security team that's doing the monitoring, or even for that matter, perhaps the developer or the ops team that's actually operating this type of tool and taking the feedback from the tool and tweaking their application against it, let alone just tweaking kind of the countermeasures within the tool itself?
Yes, exactly. So that's where that conversation can start. Is if you already have, say, you have an API that's in place, and you have a tool like Fastly or Signal Sciences WAF, you throw it in front of an API because of some kind of mandate, right, that comes down, or just because you're interested, you want to see what happens, you want to see what activity you have, what visibility you can gain. When you put that in front, a lot of the information that you get is going to require some context that only the dev side of the house is going to have, and visibility that only the security side of the house is going to have based on the implementation of their tools. If the security team's looking at some of the traffic that's coming in and just going, I have no idea what this is, but it's interesting. It's interesting to me. Why are we getting these response codes? Why are we seeing this level of traffic coming in? Maybe there's, like in the case of Signal Sciences, we have a lot of anomalous signals that we provide.
Mm-hmm.
There's stuff that we think might be interesting. We don't know if it is. It could just be boring in a specific context, but in other situations, it's very interesting. If you see a lot of that stuff, you might want to rope in your dev team and say, hey, by the way, we're seeing a truckload of 500s or 400s hitting when this sort of activity takes place. Are you aware of this? Is this something that is expected, or do we want to take a little bit of a closer look? And the dev team might take a look at it and say, wait a minute, we need to make a change here. Oh, hey, look, there's a password over here that needs to be updated, and this is actually legit activity. It's just the password's bad. We need to change it. There's all kinds of things that can be gained with that level of communication. And if you can give maybe a dashboard view of specific types of information from a security tool to a dev team and give them that level of access, or you can pull it into maybe their logging tool that they're already using. Maybe they have access logs they're gathering.
Yeah.
You can contextualize things a lot better for them and let them respond in ways that the security team alone couldn't do.
Yeah, I love that idea, because the phrase, that's interesting, I think has led to many a very successful penetration test, or a lot of consequential CVEs have been the result of such a phrase.
Yes.
And you're also pointing out, too, is that one of the things that we've harped on in the past, or we've encouraged in the past, is application layer logging, meaning logs generated by the application. But that takes time to generate, to build those logs, to code what should we log, what should we be doing. And that really resonated with me when you said just that idea of, why are we getting these 400s? Should that happen? That sounds like a great way just to start talking about the application, because it doesn't even necessarily lead to a vulnerability that's being exploited or explored. It could just be a quality issue within the application. And that, to me, already sounds like a value benefit to the developers, and a great way to build that rapport with them from the security team.
You nailed it. Rapport is key there. And I see a lot of the time there's adversity between different teams and security, and that should never be. It should always be, we are very clearly on the security side of things serving the needs of the business in such a way that they can see tangible benefit to the things that we're asking them to do, and the tools that we're asking to put in front of their stuff. If we're not providing them with some insight, we should be looking for ways to do that, so that they can understand that we're not just trying to get in the way of things. We're not trying to slow stuff down unless it's an attacker, and we're trying to enhance availability and performance of an application, not just, lock the doors.
Yeah. Well, Daniel, I do want to thank you for coming and sharing your insights with us. And the only thing getting in between us and continuing is time limits. So we'll have to figure that out. So we've been rate limited somehow already. But I want to thank you again for joining us and sharing your insights about API security.
Right on, Mike. My pleasure. Thanks, Tyler.
Cool. I also want to thank Tyler for joining us and everybody who was asking questions in the Discord. We're going to take a quick break now and return with news of the week.